You are the first participant to join the conference.
So hi, I forced to use this one because it's going to be recorded, and I'll try to. It will be really fun how I'll be typing and using the microphone in the same place. So hi, I'm Eugene. I'm from JetBrains, and so I decided to call this talk like Kotlin in 42 minutes. So it's like an introductory talk in Kotlin, and I was thinking how I can call it, and I was thinking of where to call it, like introduction in Kotlin or first lines in Kotlin or something. I just checked in Google, and there is like no talk like Kotlin in anything. And the really fun thing is that the Kotlin Action is a book, and it's a really good book. If you're trying to read something about Kotlin, it might be interesting. And the nice thing about Kotlin is like this tweet I found some times ago, and actually it's put on my Twitter feed. And it's really cool. You see that it's a green box. This is a code which is like was introduced by somebody. And the comment below, and you see the last line. This is equivalent code written in Kotlin, which do exactly the same thing. And there is like a poetry. But so I just printed this line a little bit bigger, so it's easier to read. And this is a data class in Kotlin, and we'll take a look on it a little bit sooner. But that's like how Kotlin can be used to minimize the boilerplate code, for example. And as for me, I'm not a developer of Kotlin. I'm a Kotlin user. And I'm working for JetBrains. I'm mostly doing the server side. I use Kotlin. I write DSLs in Kotlin. I do Java also, some Go programming, C, C++, Qt, and so on. And I hope I'll be able to show the Kotlin to you. And this is a really, really good resource about Kotlin. So if you have a question or if you want to try it even on your web browser, just go ahead to kotlinlang.org, and there you'll find anything you may need. Or you can ask myself. I'll be here till the end. So as for the language, the Kotlin is the statically typed programming language for multi-platform applications. It's really cool that it's 100% interoperable with Java, Android, and this means that you can use the Kotlin code along with Java code in your projects. You don't need to like rewrite anything from scratch. And it's now supported by Android as a language which you can use for Android as well. And as for history, the Kotlin started like in 2010. It was open source on GitHub from day zero. It's open like Apache 2.0 license, so you can use it everywhere you like. You can create pull requests. You can take a look what's going on in there. So everything is open. And with Kotlin, you can build applications not only for Android. Also, you can do the JVM development, as for example, I do most of my time. I do server-side development with Kotlin. You can compile Kotlin to a JavaScript code. So if you like, for example, to have a statically typed sort of JavaScript, Kotlin is for you as well. And we are working on the native. So you're able to compile the Kotlin code to a native application. If you need a small application or something where you just need a better performance without code interpretation, like we have for the rest of technology stacks. And you may say, why Kotlin? And I'm going to try to show these examples during my code session. So this is a concise. For example, you may recall the tweet I was showing like seconds ago. It's really safe because in Kotlin, the type system is done the way you are explicitly saying whether something is nullable or not. It really helps to avoid null pointer exceptions in your programs. And if you even have such, they are really easier to understand why it's a problem or not. It's interoperable. And when the Kotlin is being created, it was like 7 years ago. At JetBrains, we had like 10 years of existing Java program called IntelliJ. And it was clearly impossible to say, OK, we're starting to write anything with Kotlin. Instead, the Kotlin is designed from the day zero to be interoperable with Java. So, and now we are able to write parts of IntelliJ and other projects with Kotlin. Some parts are still in Java because they are just not changing, for example. And of course, the Kotlin is tool-friendly. There are compilers for Maven, in Maven, in Gradle, in IntelliJ. We have IDEs. IntelliJ IDE understands Kotlin. We have plugin for NetBeans, for Eclipse, and so on. So we created a language which is tools-friendly from the day zero again. And at JetBrains, as far as I know, there are about 40 people who are in Kotlin team. And we really use Kotlin in most of our products, so I put some logos over here, and I guess there are even more. So I think every Java project we have, we tend to use Kotlin in there. And as for commits and the history, I decided to have one small slide on that. The huge milestone was like 15 February last year. That was 1.0. This year we have 1.1 with more features like coroutines. And below this is the commit graph I taken from GitHub. So you can, if you like, you can take a look on this. So it's pretty active now. And so if we're trying to learn the language, and there is a really good quote from the creator of C language and the Unix, Dennis Ritchie. And so if you want to try to learn new language, or you want to learn new language, it's better to start coding with it. It's the way to understand it's better than reading a book or something. And the rest of presentation will be about the coding, so I will show some codes examples. And I want to recall this one once more. This is the documentation website. And there is a really cool thing called Kotlin clones. This is in-browser thing, or you're able to clone a GitHub repo with this. This is a set of examples. This is like 40 or 44. As far as I remember, it's around 40 tasks or exercises with explanation and all that stuff. So you can start doing this, and you'll master your understanding of Kotlin if you don't have a really project where you're going to try the skills yourself. And also we have a Kotlin Slack. So this is a place where you can go and ask questions for the community. Last time I checked that, it was like 8,500 people in there. So go ahead if you want to ask questions. It's a really good place to do. And now I have to sit down and try to fix the microphone, so I'll be able to show some code. And so you hear me now? I really hope it's possible to hear me on the recording as well. So, okay, now I switch back to IntelliJ, and I'm gonna create a new project from scratch. So most time I use Gradle for real projects, but for the sake of simplicity, I just create an IntelliJ project with a Kotlin for JVM. So I just create a native one. So, by the way, is it okay to read the screen? So, okay, now I create our first file, and I just create the Hello World application. Right, so we can start this one. Well, it works. So in Kotlin, the thing is that you declare the function with a funky word on the beginning, and the type, the parameters are declared in the braces, similar to C-like languages. The trick is that we use the name after we use a semicolon, and then there goes the type. If the function is returning something, you can specify return type over here. So on the right side, and there is again the similar syntax with the colon and the type name. The unit type is the same as void for Java, so the function which returns nothing. And if the function returns nothing, you can just remove this one. So, okay, let's create some better application. And for my example, let's consider doing a hello service, right? So let's say that this service do the really simple thing. It takes the names from the arguments, so we start the program with 0 names, and it simply prints hello to everybody who is listed, right? So we say, so we need to iterate for array and print the output, right? So we can do it this way. So in Kotlin, you can do the for each loop. It looks this way, and inside we simply print hello. We simply print hello, and we say the same as we used to use in Java, right? And let's say we are not cruel, and let's have hello. Okay, so now I need data. So I need names. Okay, can anybody help me to come up to include some names? Oh, sorry? Sorry? Donald. Okay. More names? Uh, is the spelling right? Okay. Sorry? Oh, I guess, am I putting it right?
Close enough.
Because, okay. So I'm really sorry if I misspelled it. So, okay. Now we, of course, can start our amazing application service and see how it prints names. Wow, that's good. And do you see this, the problem here in our code? This is what IntelliJ shows me, that I'm using a Kotlin slightly the way it is not supposed to be used. Slightly. This is a great highlighting. And the thing is that I can use string template instead. So I can convert it to something more readable. So in Kotlin, you are able to use this $sign in every string you have. And inside, you might pass this variable, so it will work like a template. If you need something more non-trivial inside, you may do it like this. For example, I need to call trim for a string. I can do it this way. But if we take a look on this example here, we have a really severe problem. For our service, this is really severe. We have a code duplicate over here, right? So we're creating this hello message 2 times in different ways. And let's try to play the real good application, and let's try to extract some function from it, right? So in Kotlin, the function is a fun keyword. So we say fun, we say function hello, it takes name, which is string, and it returns string. And here I can just copy this one over here, and I say return, and put it here, right? So now I'm able to fix my application somehow and say hello, and pass the name as a parameter over here, right? So, but let's take a look on this function. This is a really simple function, and so we can simplify it. In Kotlin, there is 2 ways to define function. This is the one way, and if the function returns an expression, nothing's not that complicated. You can do it a little bit shorter, and you can do it this way. So you can do it, yeah, it's visible. So you can do it, you can simply say, instead of brackets, you can say equal and expression you need. In my case, this is just a string template. And in case you're doing this, in Kotlin we have type inference. So in Kotlin we can simply omit this one as well. It's not necessary, since this is one expression, and the Kotlin compiler is able to understand the type of it. So in the bytecode, this will be the same function which takes strings and returns string. And this is a little bit short. But this one resembles me the favorite utility class which I used to have in my application, like utility to do this, that, and so on. So we tend to have like static class in Java which do some ceremony stuff in our application. In this case, this is a hello function, right? So I pass something really good, name, and I receive this answer. And in Kotlin, you're able to create an extension function. This is the thing. This is the function which plays like a member of the class, but which is not a member of the class in terms of Java bytecode. So, for example, I can create an extension function, string hi, which does exactly the same. So it returns string, and it calls our hello from this. So this is an extension function. And now I'm able to do, this thing. So I can say yes, okay, for example, and I put here hi. This is yet another way how we can express what we need. So sometimes, of course, it's good to have a function. Sometimes it's really good to replace the utilities we have with extension functions. And in Kotlin library, we have a really huge number of extension functions, which, for example, helps us to work with collections. And I'll show the collections a little bit later. And behind the curtains, this one is exactly the same function. So, for example, I can go and say, show Kotlin bytecode, and we can take a look what Java JVM bytecode is generated out of this. And here we may see that this is actually the static function which takes string and returns string. But the trick is that we declare it in the slightly other way, and we're able to use it in a yet more readable way. Oh, any questions at that point? Okay. Because is the name of what?
Yeah, it's immutable.
Yes, it is. So in Kotlin, by default, everything is immutable. This is the variables, like parameters. By default, they are immutable. And you're, for example, if I turn it back to the, let me see, if I turn it back to a block, for example, I'm not allowed to do the things like name, right? But this is nothing about the type behind. So if, for example, if you put the mutable list as a parameter, of course, you're able to change, to call anything on this type. But the reference to it, yes, exactly. And same for function in class and objects. So objects by default are final, and the methods, for example, every method by default is final, so you are not able to override it. And if you need to override it, you should say that it's open. Okay. So now I'm going to show one more thing. That's quite similar to what we have here with the extension function. In Kotlin, we are also able to create an extension property. This behaves like a field, but behind we have getters and setters. So I can say val. So I'm going to have an extension property which allows only reads. So I can say val string, for example, greet, which returns string. And now I need to implement the get. And the get in this case would do the same thing, hello, this. And now I can say turn, for example, this example, and I can turn it into the things. I put new lines to make it more readable. So I can say simply greet over here. So, for example, if I need to just to follow this the way I want my type to be converted, I can do it this way, so it just reads better. This is nothing behind. So if I take a look on the bytecode over here, this is again, this creates a method for JVM backend. This creates a static method which is called getString, which takes string and returns string. But in Kotlin, we are able to use it this way. So there are a number of cases where this just creates yet another way to make a code more precise and more readable. And okay, so we've created some servers, we've created some utilities, and now it's time to write tests, right? So let's go and create a test, for example, in Java. So test case. And now we create a function. So public void test hello, and here we create tests. So we take actual, and here we're able to access the code which we created in Kotlin. So we say main KT, and for example, we're able to call this hello function. For example, we call it from me. And now we are able to write an assertion in the way, we need to have a test annotation, so IntelliJ is able to help us to include JUnit into this new project. Now we are able to have assert, say, for example, equals, expected, I don't know what, and of course here we have actual, right? And now we can, of course, start this test, and it fails. It's okay. It's okay now. Let it fail. But I want to point the thing is that in Kotlin, you are able to create functions not only inside classes. You are able to create functions in a global scope. In my case, it's just in a root package. And in this case, these functions are accessible in Kotlin without any qualifier, without any prefixes. But when you turn back to Java, then you use the prefix where the generated code is. So you can use the Kotlin from Java and Java from Kotlin, and this is how we can do it in this particular example. And so now what I can do, I just copy this Java code, and I can paste it into our Kotlin application and in this case, IntelliJ helps me to convert my legacy Java application code into a Kotlin code. So I just say yes, it's import, and now I have this code over here, and I call it test case 2, for example, and now we are able to start this one. So this is a class in Kotlin, and it runs, and it shows the name. The most thing I like about unit testing in Kotlin is this feature. I can ask IntelliJ to help me with that, and I convert it to the name, say, test hello. Or I can say here, test hello for the presentation should and whatever I need to write here. And if I start this one, I expected to see, yeah, I see that in the test runner, I see a slightly slow here, slightly small font here. So the test name is different. And the test name, it's allowed to name methods and functions in Kotlin with these apostrophes, and you are allowed to have anything in these apostrophes. And this is nothing special about Kotlin. This is the way how it compiles the code into the JVM. So in JVM, it's allowed to have space, for example, in the method names and the class names. So this just a really nice thing that we can use freely with Kotlin, and it's supposed to work with any test runner you have. For example, with Gradle it works, with TeamCity it works, and so on and so forth. Okay. Now, maybe questions at that moment? Okay. So now let's turn to our example, and let's say we are evolving this hello service, and at that moment we need to have a specific name, a specific way to say hello to our specific users or names. And so in Java, this can be done quite easily. So we can simply say if name is Helsinki, for example, we may say return. Oh, by the way, how in Finnish to say hello? This way? This way. Oh, cool. So, hey, Helsinki, right? So we have a specific service which is able to say specific hello to our specific users, right? Or city names. And so, oh, I spoiled the cool feature. You see here, and if you're doing Java development, so do you think it will work? Well, in Java it is, but this is a luck because I use the same constant in two places. It's supposed to work, but it's a side effect. But in general, you're right. In Java, it will not work because the equal sign in Java, double equal sign, it's comparison of references. In Kotlin, this is the comparison of references, the triple equal sign. But double is the operator. And in Kotlin, you're able to overload a number of operators. And for example, this one is implemented in the Kotlin standard library. And that one does the standard equals. So this does exactly that I can write it in a Java style this way. So I can say equal, equals, and pass a Helsinki here. This is how we used to use it in Java. This is exactly the same. And IntelliJ shows me that there is a warning over here, and you're supposed to use the equal operator. You can use this. For example, in Kotlin, you may overwrite your own operators. So every standard C-style language operators like minus, plus, plus equals, unary plus, unary minus, and so on, you're able to implement those operators for your types. For example, if you have a type and you need to implement, say, for example, comparison with dates, you can do it. I guess comparison with date class for Java is implemented in the standard library, but you are able to implement these operators for your types for better readability. And I'm going to show you one more trick. In Kotlin, there are expressions. So I just fix it this way, and now I can lift the return statement. Can I? No, I cannot. Okay, so I can do it this way. So in Kotlin, the trick is that, oh, I forgot. No, I have not forgotten anything. So the idea is that in Kotlin, you are able, okay, I forgot the line. So in Kotlin, most of the standard syntax constructions like if, when, and so on, they are expressions behind. So you can use it like we used to use before. So we can use, say, like in Java, for example, you say, or JavaScript, you say if something, then return something, else return something. But in Kotlin, you're able to lift out this return, and you're able to say this one. And if you, for example, can convert it to expression body, and you can have a code like this. So you can say just equal sign, and then if one, else the other one. And this is a valid code in Kotlin. This can be used to help to make it more easier to run. And we can convert it to, also, there is a cool thing, there is a when statement in Kotlin. This is like the case statement in Java and C and JavaScript, but it's a little bit more powerful, so you can do it this, or you can use the same when without the variable this way. So here you can use anything you like, any expressions, and you can have a number of cases like this. For example, names equals Eugene, and so on. So this is the way how you can do, or you, for example, can do for an expression here like equals, and you can say equals Eugene, and please ignore case is true. And I suddenly spot yet another feature. In Kotlin, you're able to use named parameters. If you have a function with a number of parameters, and you never know what the fifth parameter means, and for some reason IntelliJ is not able to help you with highlighting around, you're able to specify, in Kotlin, you're able to specify the name of parameter, equal sign, and the value. And it plays really nicely when you have some, say, some parameters are optional. So in Kotlin, you're able to say optional parameter. For example, if I have like something string, I can say declare it this way. So if you see, in the declaration I put the equal sign and the value. This expression is evaluated every time I call this function, and this allows me to specify a number of default parameters in my function. And you see here now usages are just broken in this case, since the default parameter is being used here. Okay. Now we're gonna take to the next step of evaluation of hello service, and if there are questions, maybe there is something. Okay. Okay, so the thing is that the real service is the service where we have some database for hello messages. Let's consider we really need this, and our when statement, no matter how amazing it is, scales not enough to it. And so we need to have a function which is able to help us to find this one. So say we have a function which says find, which takes name, and which returns some object, like say we have hello item, for example, right? And let's implement it. Let's decide not to implement it for now. In Kotlin there is a to-do. This is a really cool thing. It's of type nothing. That's really a really good, nice story about this type. And the thing is that so you can do anything with to-do. You can do this way. You can say to-do this way as well. And the types are correct here. So this function is supposed to find the right name, the right way to say hello. And we need to declare this hello class. So we say class hello item. And it has a parameter like say val name. This is a username string. And val message hello message. This is the message. So in Kotlin you are able to declare this class this way. And I'm going to show you how it looks in Java. It's really a really interesting thing. So if you take a look on this one over here, I can decompile it. And so what this button does, so this one is how IntelliJ Java decompiler sees the Java code behind the Kotlin code. And here we are able to find our, where it is, yeah, hello item class. So you see, in Kotlin I did like, where it was? I did 2 lines of code. And in Java, I see the following. So I have the field name, the field hello message. I have getters in Java. I have constructor. I have equals. I have hash code. I have toString. And the whole thing are hidden. Oh, and you see, there is nothing right now, right? And the whole things are implemented with only the data keyword here. So if I say the data class, it creates toString, it creates equals, hash code, and all that stuff for me automatically. And of course you may say, that's not necessary, I can type it, and IntelliJ and other Java IDE is able to help me to come up with this amazing stuff. I can now show it. It's here, like you see. And here it is copy, here it is toString, hash code, equals. But the problem is that once you created this POJO manually, you are likely to change it somehow in some places. And once you change it, in a year somebody takes this code and decided to patch it, and then nobody knows if this code was generated, if this code was handwritten, if this code was patched, and so on. So in most cases, it's really good to say, okay, just create me this POJO, and in Kotlin, in the braces, there is a constructor parameters, and if you put simply the val keyword around the constructor parameters, this means that the Kotlin will generate the assignment for these parameters to a property automatically for you. So you don't need to take the parameter as we used to use in Java and convert it back and forth. So now we have a hello item, and now we able to update this function, and we may say val match, for example, and we call find from name, and if match, so I just trying to write the Java code as I used to use it, so I just, if it is not null, then return the specific message with match dot, let me see what's, so match, sorry? Oh, right, that's why completion doesn't work. Thank you. So, this, and we put name here, right? And you see that that's the problem here. It says me that I'm trying to compare something that is not null with null, but let's take a look on this closer. So this one is a declaration, and this is a moment where you say in Kotlin, I want to return something that is not null. And for example, if I decide to implement this function and I say return null over here, I see the wording as well. It says me that I'm trying to return null from a function which is not supposed to return null. And of course there is a fix in Kotlin. So I can say, you can add this question mark to the type declaration. And this means that, okay, I may return either value or null. And this is not the optional type as we, for example, have in Java 8. And this is a syntactic sugar. So behind the curtains, on the bytecode level, there is no overhead for it. But the Kotlin compiler is able to check whether the code is correct in the Kotlin codebase. And of course, similarly, you can say you are accepting the nullable name. And once I fixed in here, I have no problem over here. And also I have this one, this highlighted here. It says me that this is a smart cast. So the compiler is able to understand that inside this code block or inside this part of the method, the type of this is not null. So since I asserted this one over here, then it knows that I don't need to do anything. So for example, if I take this return statement out of this check, I see error over here. And it says me, I'm trying to call something that is nullable, and I cannot do this since I need a check for a null. And there are a number of ways to do it. For the trivial thing is this one. So this is the operator, which do the following. So I can extract this as a variable now, and I ask IntelliJ to infer me a type, and you see the type of it is string with quotation mark. So what it does, it checks if match is not null, and then it calls the hello message. Otherwise, it returns null. And I can move on with such an expression, and I can do whatever number of question marks in the sequence as I like it. So for example, I'd say I call length at the end. And now the type, of course, is string since the end, since this is an int, right? And this can be helpful. And finally, we have a really cool thing. We have always operator over here, and you can say, if anything wrong, just return 42, for example. So the always operator takes something that is nullable from the left side, and in case the value is null, it returns the right side of an expression. And it helps when you're trying to read, for example, POJOs from a Java, or if you have a huge domain model and you're trying to reach a number of getters to reach the value, and on every step you need to check for null. It's really, really unreadable code in Java, or in JavaScript, for example, or maybe on Swift. And here it's like, it reads a little bit better. So one more thing about the smart casts is, for example, say I have a function test. Say I take a parameter object, and any is a type is the same as object in Java. In Kotlin it's called any. And here I may say if object is how it was called. Okay, hello item, then return object hello message. Okay, yeah, I need to declare a return type over here. And here's yet another trick. Of course, I'm not able to say this one, so outside of the for loop, if expression, because here the type is any, and there is no idea what methods are there, right? But if you, in Kotlin, do a check for a type once, Kotlin is able to understand that inside the type is hello item, and you no longer need to cast it explicitly in any way. Again, it helps to minimize the boilerplate code. Because as we used to have in Java, you check instance of first, and then you switch, and then you need to cast it, you need to extract extra variable, and this thing turns out into like extra several lines. And a whole huge cast expressions in case you have like lists of something or like parameterized objects and so on. So, okay. And let's take a look closer on this find. Say we have a function which is able to load data, which just returns list of hello items, right? Say we have really simple database level or remote service backend which just fetches everything and then tries to filter a name. And this one can be implemented like a standard way. We do for it in load data, and we do if it name is equal to name, then we do return it, right? And also return no. But this is how it stands. And in Kotlin, it's possible to use the higher order functions, and IntelliJ in this case is able to help me with that. And I can do this one. And let me explain how this works. And even the ideal option is this one. And how this is inside this function, I'm gonna just copy this declaration for our example, and I take a look. So this is a function which takes a iterable in my case, or list or whatever. Let's use, for example, list for simplicity, and it takes a lambda function predicate. In this case, the lambda function, there is a lambda functions in Kotlin. You can declare these types not via interfaces, but you can simply say, I want to have a function predicate which takes type T in my case, or let's say we no longer have a generics, we just say our item here without generics, so to be more readable. So we expect a function which takes hello item and which returns a boolean. And then we're able to do the function find first not null. So find first or return null if there is no match. And of course it returns nullable hello item. And this some implementation, this is not that necessary. And if we take a look on here, we can call it this way, but the standard way is that way, right? So we call a function. We pass a lambda as the parameter in here. And there are several tricks in Kotlin which really helps to build a DCLs and DCL style expressions. And the first thing is that the parameter name of a lambda function, if it takes one parameter, by default it's called it. So if you don't like it, you can say data, and you say data. So I would name the parameter data, and I then use the parameter data. That's more explicit, that's more readable. But in most cases, if you do like data processing, like you take the data, for example, you take the data, you map it somehow, you can map to extract name, and then you sort it, and so on. It really reads better if you just use default name of the parameter instead of doing this, the long thing like I showed here. So I still remove it to item, to shorter way. And the second trick in Kotlin is that if this is the last parameter which takes lambda, you can avoid brackets. So you can do it this way, and this now reads more like a part of a language, not like a call with a lambda. And the trick here is that is not like, it introduces like zero overhead, thanks to inline functions. So in my case, this is not, but if I put this fancy inline keyword over here, the trick is that this function is being inlined to the place where I call it. So there will be no lambda created, there will be nothing extra, no extra work at all. And the whole thing is compilable to Java 1.6, so it's also possible on Android if you do an Android development, for example. And so you're able to do this. And the standard library in Kotlin, it's really huge, and we have a really huge number of helper functions which helps to work with collections in this way, way easier. And if you need a lazy evaluation, we have a sequence, and then you can use the similar functions as we used to have before, but now the evaluation would be one by one, not the conversion list to list, for example, as it used to be before, without this one. Okay. No, this is a Kotlin compiler. So there might be like sophisticated things, like for example, if you know that the using keyword in C#, like which just takes something which is disposable, and then it does something, and then you can define using in Kotlin like in a few lines. So you may say in line, fun, say, okay, let's say hello item for our using. It takes action, which goes from nothing to T, it returns T. And here you can say, for example, here you can say try, and here we call something. Why I have a problem? Okay, I have a problem because of here. And here we can do something like, here we call our action, and then we do finally block, and here we do the protocol we used to have to call this hello item. In my case, there is nothing, but say in Android API, you like start editing user preferences or doing things like that. You should never forget to like say commit to this transaction or sort of changes. And this one is being inlined in your code, and it looks really cool. It looks like this. Using. So you can simply say using over here, right, this way. And what I'm missing, okay, this is an extra thing. You can drop it. And this code looks like a keyword, more or less standard, but behind the curtains it does the magic we need to follow some protocols, or follow some patterns. And so similarly, you can do some transactions, you can do JDBC calls, you can do whatever you need. Oh, yes, and there is a remedy for it. In Kotlin, there is a trick. So, of course, yes, we are on top of JVM, so type erasure is yeah. There is this trick over here. So, if you have an inline function, so inline function is really necessary if you're trying to have real generics. And if you have it, now you're able to say, like, for example, T. So you can use T as a normal thing. You can say class. So you can use class from T. You can do whatever you like with that. You can say, for example, give a class loader or Java class or whatever you like. But the cost is that you need to say refine keyword when you declare this generic, and you need to have it in line. So the actual thing would be that the Kotlin compiler would inline this function in the call side, and there we exactly know the type you're trying to use, and that's the way to make it work. So unfortunately, this is the limitation of the platform on which we are running. This is the best thing which we have. Yeah. And it makes a little bit more closer to what we can have in C#, for example. So inlining is running on the compilation time, so the code will not change on the runtime in that sense. And yeah, so the inliner will make your method longer, and the rest is to measure whether, at what moment we hit the performance problem. Well, I agree with you, and this is what we should measure, because there are so many places where the problem can be. But the first thing I would say, if the method long enough to fit into the JVM cache for the native compiled methods, if it will be interpreted by the JVM, that first sense, this is the way more slower than the CPU cache. And once it's being compiled by the JVM to short a thing, then we may consider the CPU caches right. But this likely to have a number of problems where you can have an easier code, and only there are, like, only several of them can be like real performance penalties in that case. So this is like a trade-off we always have, like using Java, for example, not C++ or other languages. Yep. So now I'm going to switch to a presentation for a short time, and then we turn back to Q&A. So I was trying to show some Kotlin examples. I hope it was interesting. And you may take a look or ask myself about the documentation. And you definitely may consider Kotlin cons to try coding yourself. And you can do try.kotlinlang.org to try coding in your browser. You don't need to install anything. But if you use recent, for example, IntelliJ, the Kotlin plugin is included in the standard package. So you're likely to be ready for trying Kotlin just with IntelliJ in the way I just showed you with creating project. And Kotlin is being used in a number of companies, and I just put some few screenshots from a website. The Kotlin is a language for Android. It's really cool. It's, for example, being used for Gradle. So if you're doing the Gradle builds, you're able to try to write the Gradle builds not in a Groovy as it used to be before, but with Kotlin, with the statically types and with a better code highlighting and so better understanding from the IDE on what you're trying to do. And actually, this a few moments I would share what I did with Kotlin, and that's like a tweet from. I just realized that I will start using Kotlin at the moments where interfaces were called traits. It was like, I don't know, 4 or 5 years ago. And the first thing I did, it was an experiment. It was like 4 years ago now. I decided to create a plugin for existing Java application, this TeamCity, and this continuous integration tool, which we did and do in JetBrains. And I decided to create an extension which is able to run the Node.js builds. And for fun, I decided to do it in Kotlin. And this plugin is still downloadable. It's open source. You may take a look on this. And it's still alive. It still works. It was really cool to try something new back in 4 years. Then I did contribution to a spec. This is a really cool thing. You see code example on the right. This is a BDD framework which uses the Kotlin statically typed DSLs to help you to create a BDD style testing. And it was really interesting to me to help to tweak some DSL stuff and statically typed DSLs inside. And as for DSLs, at some moment I created a really, really small thing that's just a helper DSL which creates a XML with a number of function calls. And you may see here the braces here means the lambdas. They not meaning anything else. So this is, for example, the call for JDOM function, which takes tests, and the second parameter is a lambda. In this case, this is extension function lambda. And this is a really powerful way to implement such DSLs and others if you need some. And then I decided to create some sort of deserialization example. So in this case, I declare the properties, key and value, and I use a delegated properties feature of Kotlin to delegate the actually get and set of this property to some expression. And in this case, I am able to have expressions which looks like XPath queries, but which are compiled by the Kotlin compiler to me. And so if you decide, you may take a look on examples on the GitHub, because it's really nice looking, but slightly non-trivial in my code base to implement. And the last thing I did was a crazy idea to turn configuration files into DSLs. And I experimented with that with the 0 projects. It was really nice. And finally, I was able to generate the code like shown on the right side here. So this is a DSLs, and the braces again are calls for extension functions, for Lambda extension functions. And it looks really nice. And finally, I do in the server side with Kotlin. I use Spring Framework, Java 1.8, gRPC, Netty, and other stuff. And it was really nice for me. At some moment, I had like a hierarchy of event classes. I had like 10 classes, like at base event and server implementations. And it was like 10 files in Java. And at some moment, I decided to convert it to Kotlin, and I managed to move it into one file. And every class was like one line in the way I showed before, like with several parameters, and that was really concise thing. And as for statistics, we do now like 99% of Kotlin code, so new code is written in Kotlin. Sometimes we need to patch some existing Java files, which are not ready to be converted because it just consumes some time to rewrite the copy-paste the file. And like, it's really nice, and I realized that doing some asynchronous programming is really, really conciser. When you're using Kotlin, when you need to subscribe to a number of callbacks and stuff like this, it's really, really shorter and better, at least to me. And so I think we are reaching to the end, and now this is a Q&A. So if you like to see more details on examples as shown, I'm here to the end of the day and can show more details and examples. And it was really tricky to explain anything about Kotlin, so I decided to spot some best things I decided to show as a very beginning. And so, yeah, that's it. And so, thank you. Yeah, there are. So Kotlin, we are able to create a DSL, and there is such a DSL on GitHub as a small library. With this DSL, you're able to generate this. So we have a replacement to the JSX, as you have for React to define the views. And once you're able to do this, so it's being compiled to the calls to React. So the answer is yes. And you may take a look. I think we have an example, and so if you come to me, I'll show you an example. And I think it's Googleable by, let's say, Kotlin, React, and you'll see how you can use React with Kotlin. And we do use it. It works. It even works with Webpack if you use it. So. Oh, as far as I know, there are libraries, yes, and for example, jQuery, I guess, and for React, there is something. So, yeah. Yeah, as far as I know, there is a TypeScript to Kotlin converter which is able to take the type information from TypeScript and bring it into Kotlin. And of course, if you're doing the Kotlin for JS world, we have a dynamic type, so it's worse, but it can be easier to communicate with the JavaScript world, and so you're able to call anything, like whatever you like, from Kotlin back to the JS. So this is the way. And of course, we have a number of wrappers. Well, there is a really good story I heard from Andre. Is the platform modules, as far as I remember. So this is an idea how we can reuse the same Kotlin code for different backends. For example, you're doing, say, React Native application, and you are going to reuse the code which you use on a backend for your, say, JVM backend, and the same code you're going to use for your JavaScript web client, and the same code you're able to use for, say, native part of your application if you need some. And this is possible to be done today, but we are missing a small piece to make it more easier to be interop. So we need a way, and as far as I know, we're working on this, to say these several methods or classes or whatever, I don't know, are being implemented by every platform with a specific way. And then I am able to move my, say, business logic into pure Kotlin code, and then I'm able to reuse it on all my targets. And this looks really amazing to me. I'm really wondering and want to try it. Yeah. Well, I did use it, but I'm on the way to use it in my project. But now I'm really regretting that I was not able to speak about coroutines here. But you know, it's like extra 40 minutes talk. So, yeah, the point is that we created the coroutines, but we are not certain if we did it in the best possible way and if we are not missing anything. And that's why they are experimental. And there might be some changes. Actually, I don't know if But what I know is that they're going to be a conversion action in IntelliJ. So if you decided to use it, you can use it now. And when you will be upgrading to the next Kotlin version, their IntelliJ will help you to convert your code to this new version of coroutines. For example, the package change, or which is possible to be, because there is a experimental in the package name now. And I guess there will be no problem. But if you're gonna try it, share your experience, because yeah, it's really useful. Well, in Kotlin, if I understand the question correctly, so in Kotlin you're able to use, so for example, you can take, for example, Kotlin 1.0 with no coroutines, and you can do React, RxJava, for example. And the help would be that you just have shorter lambdas in this case. And so if you decide to use coroutines, you can use it in several different ways. And the main trick is that you see the linearly looking code, which is being executed in a way you define in your library. That's the trick. Well, no, there is no such requirement. So in most cases, I think in all cases, so there is no reason to fix any indents in your code. But of course, IntelliJ tend to help you, and the code formatter will help you to have it like in a sort of standard readable way. But it's up to you. There are some examples. For example, if you define the property, then the get should be on the next line. This is the whole thing. But there is nothing that depends on how many spaces you have before and after.
Related to that, do you guys have any like code formatting standard, like or a tool for doing that, or do you rely on like how do you put the space between the variable and the type?
Oh. Well, also sorry for that. Then it looks like it was my mistake. I'm trying to fix it. But as for code formatter, which is included in IntelliJ, it does not do this. So there is no space between the variable name and the colon, and there is a space after colon and the type name. And as far as I know, there is something. Maybe there will be some standards, some things, but I currently have no idea. So I tend to use. So yeah, I can show it. That's not so similar to JavaScript, but let me switch to an IDE. You can do the things like, so you can say map of, you can do map of, and you can say A to, say 42, and so on. This is one thing. And we have list of course, we have list of, array of, which allows you to create the simple construct. If you need more complicated things, you open to create your sort of small DSL. For example, this tool keyword here, this is an infix function. So if you add the keyword infix in the function declaration you have, you're able to call it this way, without dots and with spaces instead of. And this opens a way to create a DSLs, and as I just shown this example for that one. So you can create something like this, which in the best way fits your needs. So you're able to create a DSLs, and you're able to, for example, if you like it, you're able to overload operators, and you're able to use it, like instead of saying attribute, you may say plus, or instead of saying element, you may say C/, for example. And if we go further, I think we can, let me try Kotlin HTML. If we try, so I'm trying to Google Kotlin HTML builder, and this is a really, really nice example of how DSL, is it readable? Yeah, you see it? So this is a DSL, this is a statically typed thing, and you can say, okay, I need to create a body. Inside the body I have a div, inside div I have link, and so on. This is a normal Kotlin program. There is no magic inside. And all types are known here. So you can have code completion, you know for sure you're not doing something wrong here. And this is the way to create builders for any specific stuff if you need it. Well, yeah, if you Google it, you may find several things, but I guess the right story is that there is an island near St. Petersburg, Russia, which is called Kotlin, and I guess the name is from here, from there, not from ketchup. Okay, so I think I'm done now. So I'll be here, so if you have more questions, so I'll be happy to answer. And I'm giving the place for the next one. And
yeah, I guess we could then take a couple minutes break.
Okay.
Before John's talk. Go to the washroom. The bathroom's just over there. Eugene, again, for coming all the way from